Let me start.
Okay, ma'am. So, good afternoon, everyone. So, we're going to have our post-lab discussion for Activity 4, which is entitled Measuring Volume. So, for our objectives, first, to supply the different information for the different types of pipette. Second is to make a schematic diagram of the procedure. And last is to discuss the process of calibrating the different laboratory instruments. So in using a pipette, we have different types of pipette, and the first one is the volumetric pipette. Its type of calibration is TD, which means to deliver, and its function is for delivery of fixed volume, and the available capacity is 1 to 200 ml, and the type of drainage is free. The second one is the Moore pipette. The type of calibration is TD, and its function is for delivery of variable volume, and the available capacity is 1 to 25 ml. And the type of drainage is to lower calibration line. Next is the serological, and the type of calibration is TD. Its function is for the delivery of variable volume, and the available capacity is zero point 0.1 to 10 ml. And its type of drainage is blowout last drop. Next is the serological. PC man. Doble lagi dyan.
Doble jud na siya ang lambda.
Ang
Ay,
serological, ma'am, nagdalawa ka TD, dapat isa ang TC.
sige, let's see later. Sige, go.
So, ang isa is serological TC. It is used to transfer a desired volume of solution from one container to another. And the available capacity is 0.1 to 10 ml. And the type of drainage is to lower calibration line. And the next one is Ostwald-Follin. The type of calibration is TD, and its function is for the delivery of fixed volume. The available capacity is 0.5 to 10 ml, and the type of drainage is blowout last drop. Next is the lambda. The type of calibration is TC, and its function is for the containment of fixed volume. The available capacity is 0.001 to 2 ml, and the type of drainage is washout with suitable solvent. Next is the lambda. Type of calibration is TD, and its function is for the delivery of fixed volume. The available capacity is 0.001 to 2 ml, and the type of drainage is blowout last drop. And lastly is the Eppendorf. The type of calibration is TD. Its function is for the delivery of variable or fixed volume, and the available capacity is 0.001 to 1 ml, and the type of drainage is tip emptied by air displacement. So the next one is cleaning the pipette. So the first step in cleaning the pipette is dapat maggamit ka ng rubber bulb to draw the detergent solution. Tapos dapat i-make sure mo na ang solution is makaabot siya sa level 2 to 3 cm above the calibration mark ng pipette. Then after that is dapat i-drain mo ang solution, then i-rinse mo ang pipette gamit ang tap water. Then next is i-inspect mo dapat ang pipette for film breaks. Then if necessary pa ang cleaning, i-repeat mo lang yung process na ginawa mo. Then i-fill mo yung pipette ng distilled water. So dapat mga 1/3 ng capacity, and then i-rotate mo siya dapat i-rotate mo siya para ang entire interior surface niya is mabasa. Then, ang rinsing step is ulitin mo siya at least 2 times.
Hello. So for measuring an alico, first is use a rubber bulb to draw volume of liquid to be sampled into the pipette. Then thoroughly use the entire interior surface. Then repeat at least 2 additional portions. So what is the purpose of this procedure? So the purpose of this procedure is to make sure that the pipette is clean and to avoid contamination. To ensure that it is clean pipette and there is no bubble or liquid inside. So meron din kaming na-search na reason or purpose kung bakit clean natin yung pipette natin. Kasi nga, yung pipette is made of glass siya, and then it can absorb and retain water on the surface. So because of the polarity of the glass and the intermolecular forces, thus you have to rinse the pipette with the solution you will use because distilled water can change the concentration of the initial solution and will produce an incorrect result. So for after na thoroughly na clean yung pipette, carefully fill the pipette to a level somewhat above the graduation mark. Then quickly replace the bulb with a forefinger to arrest the outflow of the liquid. So note, make certain that there is no bubble in bulk liquid or form na sa surface. Then tilt the pipette slightly from the vertical and wipe the exterior free of adhering the liquid. Then touch the tip of the pipette to the wall of the glass vessel and slowly allow the liquid level to drop by partially releasing the forefinger. Then further flow as the bottom of the meniscus exactly with its graduation mark. Then place the pipette tip well within the receiving vessel and allow the liquid to drain. So when free flow ceases, rest the tip against the inner wall of the receiver for a full 10 seconds. Finally, withdraw the pipette with rotating motion to remove any liquid adhering to the tip. So the small volume inside the tip of the volumetric pipette should not be blown or rinsed into the receiving vessel. So using a burette. So for cleaning, so first is thoroughly clean the tube of burette with detergent and a long brush. Then rinse thoroughly with tap water, then with distilled water. So after na-rinse ng distilled water, i-inspect for water break. Kung meron pa rin mga tubig, repeat the treatment if necessary. So the purpose of this is to rinse the burette to make sure that it is okay to use and also para makakuha tayo ng tama na result. So for filling, make certain that the stopcock is closed. Then add 5 to 10 ml of the solution to be dispensed and carefully rotate the burette to wet the interior completely. So, nag-a-add tayo ng 5 to 10 solution na gamitin sa burette. Kaya, di ba ito ang basic na ginagamit for cleaning the burette kung anong solution ang gamitin mo na i-measure. Then, allow the liquid to drain through the tip. Then, repeat this procedure at least 2 or more times. Then, fill the burette well above the 0 mark. Then, free the tip of the air bubbles by rapidly rotating the stopcock and permitting small quantities of titrant to pass. Then, lower the level of the liquid just to or somewhat below the 0 mark. So, allow for drainage of equal to 1 minute and then record the initial volume reading, estimating to the nearest 0.01 ml. So, sa initial reading, ang given namin is 0 ml. Kasi gitingnan din namin yung lower meniscus niya. So, nandoon siya sa 0. Then, sa final reading is 17.3 ml. Clear, guys? Makita niyo ang picture.
Opo.
Thank you. So, for the volume delivered, so, isubtract lang yung initial reading and the final reading. Kaya nakuha namin ang 17.3 ml.
Madunggan ko.
Oo, just
Ingnalang ko nyo kay nag-sign mo good na your internet connection is unstable. Ingnalang ko may kung naputol-putol. So, for the letter C, using volumetric flask, nasal number 1, for cleaning, volumetric flask should be washed with detergent and thoroughly rinsed. Then, only rarely do they need to be dried. If required, however, drying is best to accomplished by clamping the flask in an inverted position. Then, lastly, for the cleaning, insertion of glass tube connected to the vacuum line hasten the process. Next, John. For cleaning, ito tatlo lang ang kailangan for cleaning. For second, direct weighing into the volumetric flask, introducing of known mass of solute to volumetric flask, like directing, hindi ko mabawit lang, hindi ko mabasa. Direct prepare of standard solution. Then the second procedure is use powder funnel. Hindi ko talaga siya mabasa na part. It minimize the possibility of loss of solid during transfer. Then third, rinse the funnel thoroughly. Fourth, collect the washing in the flask. Fifth, wait lang. Foregoing procedure may be appropriate if heating is needed to dissolve the solute, instead weighing solution in the beaker or a flask. Then, add solvent, heat to dissolve the solute and allow solution to cool to room temperature. Then, transfer the solution relatively to the volumetric flask as described in the next section. Next, John. Then, insert the funnel into the neck of the volumetric
Loading
flask.
lang.
Ha? Putol-putol?
Go.
Putol-putol, John?
Dili man, okay lang. Loading lang
Ah,
kayo ang
Ay,
ang
okay.
akong
So,
wifi mo. Dugay kay siya makita sa inyo ang screen.
So for the third, quantitative transfer of liquid to the volumetric flask. So first, insert the funnel into the neck of the volumetric flask. Second, use a steering rod to direct the flow of the liquid from the beaker into the funnel. Third, tip off the last drop of the liquid on the sprout of the beaker with steering rod. Fourth, rise the steering rod and interior of the beaker with distilled water and transfer the washing to the volumetric flask as before. Then last, repeat the rising process at least 2 more times to ensure na ano siya, okay. So for sa ika-apat, dilution of the mark. So fill the flask about half full para mas madali. Then swirl the content to Huston solution. Add solvent to the mix. Add solvent and mix. Then drainage time is 1 minute. Liquid level is almost near at the mark. Pag makita nyo na yun siya doon. Then lastly is transfer contents to the storage bottle. So medyo gikontian ko siya kasi parang madami siya at hindi ko na talaga siya makita. Next. Wait lang, taas ka siya. For the guide question, so the letter B is discuss the process of calibrating the following instrument. So first, sa letter A is calibration of the pipette. So take a clean 100 centimeter cube in a conical flask fitted with a cork or stopper. Weight the conical flask with the cork accurately on the analytical balance to the nearest milligrams and record its mass in your notebook. Then take the pipette out, those 10, 20, and 25 centimeter cube or the equal to the capacity of the pipette. If wala, so of the distilled water from a beaker into the conical flask and weigh the flask with its content. Then record the temperature of the water with a thermometer. Calculate the mass of the water delivered from the difference of the two readings. Repeat the process 2 to 3 times. Take the average of mass and divide it by density of the water at a temperature to calculate the equal capacity of the pipette. John, next. So, ang second na kunin ang i-discuss ang calibration is ang burette. So, take a clean 100 centimeter cube flask fitted with a cork. Measure its mass accurately to the nearest milligrams on an analytical balance and record the mass. Clean the burette thoroughly and grease the non-cork properly. Stop cork properly. Then fill up the burette with distilled water and note the room temperature. Adjust the water level to the 0 mark. Touch the tip of the burette to the wall of the beaker to remove any adhering drop. Take the initial reading of the water level in the burette. Then second run the 10 cm cube of distilled water in the conical flask. Touch the tip of the burette to the wall of the flask cork the flask and weigh it accurately on the analytical balance and record the mass. The difference between this mass and the initial mass of the flask gives the mass of the water delivered. Then calculate the volume of water actually delivered by dividing the mass by density of water. So repeat the process with the 20 cube centimeter, 30 centimeter cube, baliktad pala, 40 centimeter cube, and the 50 centimeter cube water, thus calibrating the breath over its entire length. So, iulit lang yung process sa nasabi ko kanina. John? Wait lang, taas ako dun eh. Wait lang. So third, the calibration of the volumetric flask. So volumetric flask may also be calibrated in a manner similar to the described for burette and pipettes, but their large volume requires the use of oversized analytical balance. Therefore, the volumetric flasks are calibrated by the procedure described below. So take a clean 250 cm cube volumetric flask using a calibrated 25 centimeter cube pipette. Carefully transfer the 25 centimeter cube of distilled water 10 times in succession to the flask. If the water level in the flask does not correspond with the mark of the neck of the flask, paste a label with its upper edge on the level with the bottom of the meniscus of the water. This will present the correct calibration of the flask. You can similarly calibrate the volumetric flask and the other capacity if required. Oh my god, the internet is not stable. If you want to find the true volume of the water in the flask up to the graduated mark shown on the flask, you may do so with the help of the calibrated burette by transferring the water. Wait, kita. Transferring water exactly up to the graduation mark. So for our conclusion, in this activity, we learned that there are 3 types of measuring the volume. We have the pipette, the burette, and the volumetric flask. And in this activity, we learned that there are different types of pipette based on there are I think 8. I think may 8 na pipette na then we describe natin based on their calibration, function, available capacity, and type of draining. And lastly, we learn about the proper cleaning of materials, which is what we are doing in the laboratory is the total opposite of it.
That's all for our report for the activity number 4. Thank you for listening.
Okay, so thank you for that report. Before I'll have the discussion sa activity, do you have questions, class? Anything that you would like to ask the reporter? Wala.
Very good, classmates.
Sige, I'll stop share this one, ha? And then, sa inyong Schoology na account class, I had given you already the copy of the slides sa post-lab sa activity number 4. Though, may I remind all the reporters, I mean, you can have your representative only to submit a copy of your report dito sa Schoology. You can see there laboratory report so that I can grade your reporting. So for now, wait lang, let me open it. Let's see if your answers are correct. Tanaw na to if we have the same answer sa inyong activity number 4. So we have this. Wait. So again, activity number 4 is entitled Measuring Volume. Ayan. Let's see again if we have the same answers for this activity. So do not forget, class, that our units for concentration are liter and milliliter. Pag sinabing liter, that's 1 cubic decimeter. And mao na siya ato ang standard unit sa concentration. Very pink, very girly. Ano dyan ano? Very girly. Dyan na basta ako ang mubuhat. I really like pink. Matrak ko sa pink class. Anyway, and then for the milliliter class, this is 1,000 of a liter. We use milliliter if it's inconvenient to use the liter. For example, we will be measuring small amounts of volume only sa liquid. Then it's convenient to use the milliliter. Now, we have the following volumetric equipment ginagamit natin to measure or to contain our liquid. We have the pipette, that we use if we want to transfer liquid from one container to another. And then we have the burettes. You know it very well. Ang itsura sa atong burette, it's a tube with graduation marks, and at the end of the tube, the glass tube is a stopcock, and that is used to control the flow of the liquid from the burette. And then the last one, yeah, we have the volumetric flask class, na ginagamit siya to most likely to contain, okay? To contain ang ato ang volumetric flask, it's a flask with a long neck, and then you can only see one graduation etched on the neck of our volumetric flask. So it will just give you one measurement only. So again, this is to contain solution, especially if we want to make a stock solution. Well, let's start with the using of the pipettes. We have different types of pipettes class. We have the volumetric pipette, which is used to deliver. And to be exact, ang volumetric pipette is used to deliver the fixed volume of our liquid. So we have different sizes of our volumetric pipette. It can be 1 ml or it can be a big volumetric pipette that can accommodate up to 200 ml. Now, this one is a free-flowing class in terms of its drainage. Free-flowing lang ang ato ang volumetric pipette. And this is how a volumetric pipette looks like. You can easily identify volumetric pipette by the presence of a bulb, like this one at the center. And again, it will deliver fixed volume. If it's a 100 ml volumetric pipette, it will really deliver 100 ml. So, in anaha ang volumetric pipette. And then, aside from that, we have the Moore pipette, which is also used to deliver, but this time, variable volume. So, ang available capacity natin with the Moore pipette, is much lower than the volumetric one kasi we only have 25 ml na Moore pipette. And paano kung i-drain natin ang liquid? We have to drain it just lower than the calibration line. Now, let's see the difference between the look of the volumetric pipette and the Moore pipette. So, kanang ginagamit nato sa eskwelahan class, we have a lot of Moore pipette in the school. So, as you can see, it is graduated, daghan siya og kanang graduation marks, and it can deliver variable volumes of our liquid. So if you want to deliver 10 ml, you may do it. You can even do it with 7 ml. Kung gusto nimo 7 ml imuhang i-deliver. So mao na ilahang difference ni volumetric pipette. So it's the same thing. We will connect this with a bulb, a rubber bulb to draw liquid or solution from the container. Okay, And then we have two types of serological pipettes. Both are used to deliver and to deliver variable volume. So meron din tayong parehas na capacity, it's just that they have different types of drainage. Meron tayong serological pipette na blown out pipette, meaning you have to really blow out everything, all the liquid sa loob should be drained. Let's blow out until the last drop. And then we have a serological pipette na you just have to drain the liquid inside, just lower the calibration line. So this is how a serological pipette looks like. What's the difference? I mean, parehas sila sa more pipette na graduated. But ang difference nila, class, most of our serological pipette is graduated up to until almost the end of the pipettes. If this is the end of the pipette, most of them kay class, naapay graduation until almost the end. While ang more pipette manggod is actually, layo siya sa end sa atuang pipette. Kasi more pipette is not a blown out pipette. Ang serological, meron siyang blown out pipette na klase. Ang more manggod mo, nang layo siya sa calibration line, after draining this, may mabilin pa na siya dinha na liquid, and dili nimo siya kailangan huruton kasi mo na ang iyahang calibration. While sa serological pipette, pag blown out pipette siya, you really need to drain everything kasi included ang tanan dito sa iyahang graduation, sa iyahang calibration. Okay, and then we have the Ostwald-Follin pipette. This is also calibrated to deliver, but this time parehas siya kay volumetric pipette na fixed volume. So you will expect here na you only have one graduation pag Ostwald-Follin pipette, and this is unlike volumetric pipette, this is a blowout last drop pipette or a blown out pipette. So this is how an Ostwald-Follin pipette looks like. Though it also has bulb just like the volumetric pipette, pero dili parehas no ang ilahang appearance. Now para asa si Ostwald-Follin pipette, class, other name for the Ostwald-Follin pipette is the blood pipette. Okay? So ginagamit ni siya na pipette for blood chemistry kasi ang niya purpose is to deliver fluids na viscous just like the blood. So pero dili siya exclusive for the blood ha. We can use the Ostwald-Follin pipette for other fluids that are viscous if you want to transfer a certain measurement from one container to another container. So I hope that is clear about the Ostwald-Follin pipette. And then let's go back to the table. We have two types of the lambda pipette. We have the one for to contain fixed volume of liquid, and then the other one is to deliver fixed volume of liquid. So same sizes lang sila, however, they also differ in terms of the type of drainage. So sa lambda na to contain, gina-wash out siya totally, but you have to do it with a suitable solvent. So kung may maiwan na liquid sa loob, you really have to drain it totally with the help of a solvent that is non-reactive or is helpful or suitable with the solution. While the lambda pipette that is used to deliver fixed volume of liquid, it's a blown out pipette. So huruton tanan but without the aid of the solvent. So this is how a lambda pipette looks like. This is actually a small pipette na ginagamit din natin to deliver syempre or to transfer small liquid volumes down to 1 microliter. So this is different from micropipette ha. This is lambda pipette, though parehas sila na ginagamit for small amount of liquid. Okay, and then the last one we have the Eppendorf pipette. This is also used to deliver, but depende siya. We have class Eppendorf pipette na used to deliver fixed volume. Pwede po siya variable volume of the liquid. So it can deliver actually small capacity, 0.001 ml to 1 ml. And then, ano siya, the tip is emptied by air displacement. Therefore, the Eppendorf pipette is what we known as the class, micro pipette. So, naani siya tip, diba? I believe nakagamit na mo ani. And ano ni siya, you have to drain everything. Kay kaduha man ni ka-stop. If we push this button here, i-push ni mo siya, first stop, madrain na niya ang musulod sa tip. And then another push pa jud, second stop niya is for the air displacement para mahurot tanan sulod dito sa pipette. So blown out pipette siya gihapon pero with the help of the air. So air displacement ang iyahang way sa pag-drain. Questions about the types of pipette, class? Wala. So I hope you can identify this one is a Moore pipette. This is more common in the school. And then the volumetric one, you can identify it with the one graduation only and the presence of the valve. And then this one is a serological pipette, but most of our serological pipette is graduated until up to almost the tip. And then the Ostwald Follin pipette that is used for blood chemistry. This one, though wala nakabutang ang name, this is an Eppendorf pipette, or we simply call this a micropipette. And then the last one here, this is our lambda pipette. So just like the Eppendorf, ginagamit nato siya to deliver or to transfer small volumes of liquid. Okay? And then for the cleaning sa pipette, I will not dwell on this any longer. You can rewatch the video from the YouTube if you want to learn again or to relearn how to clean the pipette. Dili na nako siya thoroughly i-discuss. And then sa measuring and aliquot, I have only placed the first part because you have to explain why we are doing this. So mo ni siya ang ginapa-explain, class, tong procedure na use a rubber bulb to draw a small volume of the liquid to be sampled into the pipette and thoroughly wet the entire interior surface. Repeat with at least 2 additional portions. So you have to explain why we are doing this before using the pipette. So by rinsing the pipette with the solution, you are actually making sure that the concentration of the solution in the interior surface or the inside the pipette will be exactly what you want it to be. So for example, your solution is 1M. The correct term here is actually acclimatization. You are acclimatizing your pipette for the certain solution with the correct na what do you call that, concentration. Kasi there will be instances like, diba, you will be washing your pipette before use, and then there will be instances that water will remain inside. And kapag hindi ka mag-acclimatize ng iyong pipette, those water inside na naiwan will be included in the solution, and then that will dilute your solution, making your concentration lower than the original or the desired concentration. So again, the purpose is for acclimatization, para ma-make sure natin na the same pa rin ang ang concentration ng ating solution even masulod na siya dito sa pipette. So I hope that's clear. Question so far? Do we have the same answer sa inyong ipasa nga activity 4? Parehas tag-answer? Dili. Okay, sige. So how about using a burette? I will not dwell also more with the cleaning and the filling. You may always watch the videos, the sample videos sa YouTube. So I have provided the link. Now sa explanation gihapon sa rinsing, that's the same purpose with that of the pipette. So you have to rinse your burette with the solution that you're going to measure and deliver so that ma-acclimatize siya and ma-ensure na the same ang concentration sa ato ang solution all throughout. Dili makadagdag ang water sa sulod sa iyahang concentration. Now, I guess we have the same reading also. Tanaw na ko kagaina sa report nila Jonabel. So the initial reading here is 0, and then the final reading is 17.3. You just have to subtract final reading and then initial reading. You can get the volume delivered. So sa burette class, it is not really necessary to start with 0 kasi you can still get the volume being delivered even if you start anywhere in the burette. Okay? Minus lang nato. So the volumetric flask, you are very much familiar with this. This is a flask with a long neck and one graduation mark only etched at the neck. So if it's 1000 ml, then you can only measure 1000 ml here. Volumetric flask is just used to contain solutions and very, very helpful when we want to make stock solutions. Like if you are asked to make 1 m sulfuric acid, then you can do that here using the volumetric flask. Now, how about for the calibration? Paano nato siya i-calibrate? Actually, ang inyuhang report is also another way of calibrating the equipment. However, I will be teaching you another way here. Almost the same, but we have computations here. And then we have table. Pero wala na ko ginaingon nga memorize ninyo ang table. Kay medyo daghan-daghan siya no. Buang tag-memorize ani. Sa quiz or sa exam, I will let you look at the table for your reference. Okay, let's start with the calibrating a volumetric pipette. So, unsay himuon nato pag mag-calibrate ta og volumetric pipette? Ang first step actually is, syempre, di ba, pag nagagamit kag pipette, i-transfer nimo ang imuhang liquid from one container to another. So, in calibrating the volumetric pipette, wait, let me admit. Okay. The first step actually is to weigh the receiving flask. Ayan, receiving flask, including the stopper ha. So that's the first step. Determine the empty mass of the stoppered receiver to the nearest milligram. So actually, pwede po in grams. And then, after that, mag-transfer ka na ng water ang ginagamit sa calibration class. So you transfer the water. This time, the water is equilibrated to a certain temperature ha. So you have to take note of the temp of the water. So using the pipette, i-transfer siya dito sa receiving flask. Wait lang, kay daghan og disconnect tapos trying to reconnect again. So say maputol-putol ko. Wait, sig nag-chat pa si Din. Tingog ako cellphone. Yang nataan eh. Sige. And then, ang next step class, isa-isahon nato no kay usahay manggod kapoy magbasa og mga kaparagraph ba. Sige. Wala gyapon natarong inyong globe. Okay naman mi diri sa balay. Di lang mababaan. Okay na mi diri. Okay. After that, you have to weigh again. So weigh again the receiving flask. Pero this time, with the stopper plus the water na imuhang gi-transfer. So, muna siya ang step sa pag-calibrate sa volumetric pipette. And then, number 4, you have to compute for the mass. Mass of the water. Paano nimo i-compute ang mass sa water, ani? So, paano siya? Just have to subtract weight of the flask, katong receiving flask plus the water, minus the weight of the empty flask. Okay, you will get the mass of the water. Okay? Scam ang globe. Taitan. I hope nakuha to. Klaro? Questions about the calibration of the volumetric flask? Wala. Sige, let us continue. And then class, we will be using this table to get the volume, okay, na na-deliver sa atuang pipette. Okay? So this is our formula. Volume delivered is equal to the weight of the water times volume at temperature. So I'll give you an example sa sa pag-calibrate sa atuang pipette. So we have here, nado kay 25 ml na pipette, and then during calibration, naka-deliver siya. So ano na ni siya, human nag-minus no ang container, nakuha na nato ang mass sa ato ang water. It's 24.976 grams of water weighed against a stainless steel. So mo ni siya ang container, I mean ang kanang component of the analytical balance na gigamit, and the temperature during weighing is at 25 degrees Celsius. So use the data in the table in the previous slide to calculate the volume delivered by this pipette at 25 degrees Celsius and 20 degrees Celsius. So ang weight sa water class again is 24.976. Tapos, i-multiply nato siya sa volume at temperature. Remember class, 25 degrees Celsius. Balik ta sa atuang table. So, pangitaon ni mo diri ang temperature. So, we have here the 25 degrees Celsius. And at 25 degrees Celsius, water weighs 1.0040 grams per ml. Ano iyahang unit? Nasundan to, at 25 degrees Celsius, water weighs 1.0040 grams per ml. So, muna siya atong i-times. Kung nakita ninyo, 1.0040, ml per gram. Okay, ang isa ka gram daw sa tubig at 25 degrees Celsius is, iyahang volume is 1.0040. So, i-multiply lang nato to correct to get the volume delivered. So that's 25.08. So supposedly manggod 25 ml pipette lang siya. Pero at 25 degrees Celsius ang na-deliver gyud niya na volume is 25.08. Now paano kung babaan nato ang temperature? Remember di ba ang temperature na ay effect sa pag-weigh. So balik gihapon ta didto. The weighing is still at 25 degrees Celsius, but if we want to correct it kasi 20 degrees Celsius man example ang nakabutang sa pipette dapat, so diri gihapon imong reference kay mao man ni ang temperature during weighing. 25 pero dito ta sa corrected na 20 degrees Celsius. So that's 1.0037. Okay, remember na pag nagababa ang temperature, nagagaan pod siya. Nagagamay ang water di ay. So muna siya i-times nato siya diri sa katong na weigh nato nga weight of water. Times nato siya, and then at 20 degrees Celsius class, pag multiply nato, actually ang iyahang ma-deliver is up to 27.07 ml. So mauna ni siya ang corrected volume or the true volume na na-deliver. Na diri ang effect ni temperature. Okay? Questions? Questions, class? Wala. Nasundan ra to. Okay, so let's move on. Kung wala pangutana, let's move on sa calibration sa burette. Ang burette gyud ang taas og kanang class procedure sa pag-calibrate. So isa-isa ho nato siya. So ang pinakaunang himuon, you have to fill. Butangan nato ang burette with that water nga temperature equilibrated ha. ibutang na to, i-fill na to ang burette with that water and make sure na walay bubbles na na-trap. Now, we have to get rid of the excess. So, syempre, we have to drain the liquid or the water inside up to the, ang iyahang bottom of the meniscus is at 0.00 ml mark. And then we have to make sure now we have to remove excess na mga liquids, especially at the tip of the burette. So ito siyang i-touch dito sa tip sa itong receiving vessel like the beaker. And then wait for 10 minutes and recheck the volume. Ano ni siya, kapag walay pagbabago sa volume na agihapon siya sa 0.00 ml mark, then mo na siyang ginaingon nga your stopcock is already tight. So during this interval, you have to weigh your receiving flask. Okay, kaning iyang ginaingon diri nga during this interval, weigh to the nearest milligram a 125 ml conical flask fitted with a rubber stopper. This is your receiving flask. Okay, so kuhaon nimo na siya empty ha, pero pwede siya nga naa siya stopper, naa siya kanang closure bitaw or kanang sa pag ginagamit rubber stopper or usahay man good kay cork pero dili man good siya actually recommended ang cork. Anyway, basta naa siya closure, basta empty lang siya. Now, once na ma-ensure nato na wait lang. Once tightness of the stopcock has been established, okay na to. So mag-transfer na ta og approximately 10 ml of water to the flask. Take note, it's 10 ml water. I-transfer na to. Makita man na nato siya sa burette, diba? Kay magsugod to sa 0 mark up to the 10 ml. I-transfer na to sa flask. So, i-make sure na to nga tanan na transfer sa flask. We even have to touch the tip of the wall of the flask para mahurot tong tanan nga liquid. Maabot siya tanan sa receiving flask nato. And then we can refill the burette after. And then katong flask class nga receiving vessel nato, i-weigh nato siya ulit. Okay? I-weigh nato siya ulit. This time na siya water nga approximately 10 ml content. So parehas lang po siya sa burette class na the difference between the weight of the container plus the water and, di ba, i-minus nato sa weight of the empty container, that will be the mass of the water. Okay? That is the mass of the water. And gamito nato na siya to get the true volume and the difference between the true volume and then the apparent volume. So ano ni siya, kanang ginagamit nato siya to correct the reading sa atuang burette. I'll give you an example. Kay kaning next nga step is just the repetition of the first step. Kasi ulit-uliton dapat nimo ang imuhang procedures. I'll give you an example. So for example, class, di ba, ang volume na nag-deliver is approximately 10 ml. We actually call this the apparent volume. Ayan. And then, for example, the weight of the flask na empty, this one is empty, is like 29 grams na akong gamiton. 45 grams. And then the weight of the flask plus the water is like 39.15 grams. Okay. For example lang ha, kana siya. And then, ang next step, ana, is diba to compute for the weight of the water para mabalaan nato ang true volume. Unsay himuon, i-minus lang na siya. Weight of flask plus the water minus the weight of the flask. You will get the weight of the water. So that's 39.15 minus 29.45 grams. This is in grams. Ilan yun siya? You have your calculator there? 39.15. May nag-message man. 9.7. Sige, sige. Sige, 9.7. So, mauni siya ang weight sa atuang water. And then, gamito nato itong formula. Kung unsa tong formula kagaina sa pipette class, mao gihapon to ang gamiton dinhi. Diba? Volume delivered is equal to the weight of the substance, or the weight of water, I mean. Let me, ito ang specify, weight of water. Okay. Weight of the water, i-multiply nato siya, di ba? At volume at P. Volume at P. So for example, ang weighing nag-take place at 25 degrees Celsius, and then you want to know the volume delivered at the same temperature. You want to know the volume delivered at the same temperature. So weight of the water here, ang computed nato is 9.7 grams. I-multiply nato siya sa volume at temperature, meaning kailangan nato class ang table para mahuman nato ni og compute. So ingon ko 25 degrees Celsius ko. So mao ni imuhang reference. Pangitaon nimo ang 25 degrees Celsius. We have it here. And you want to know the volume delivered at the same temperature. So at 25 degrees Celsius, the volume delivered is 1.0040 ml per grams. So mao na gihapon ang atoang gamiton. 1.0040 ml per gram. So makancel man ni ang grams, mabilin ana is ml. So 9.7, wait, can you compute? 9.7 times 1.0040. Ayan, 97. Tama. Ay, sorry, 9.7388 ml. So class, mauni ang apparent volume na na-deliver, but this one is the true volume. Okay? This one is the true volume. Now, you will get the difference. You will get the difference between the true volume and the apparent volume. So this is just 10 ml minus 9.7388 ml. So what is their difference? 10 minus 9.7388. This is 0.2612 ml. Take note of the difference ha. Anyway, gichat man ni Majeda no 0.2612 ml. Now nganong kailangan nato na siya mabalaan? Kay we will stop calibrating the burette if ang imuhang difference between the true volume and the apparent volume is plus and minus 0.02 ml. Meaning ato, pag kana na lang ang difference sa apparent o sa true volume, calibrated na imuhang burette. And human na ka sa process of calibration. But this time, since ang ato ang na-compute, na difference is 0.2612 ml. Layo pa siya sa 0.02. So you have to continue. Repeat the procedure from procedure number 1. Nakuha? That's how you calibrate a burette. Questions, class? Walay. Sige, and then the last one is for hindi na mabalik. Mabalik yapon siya. Kay compute man to nimo siya ulit. And then kung makuha na nimo ang difference between the apparent and the true volume, and then ano siya, plus and minus 0.02 na lang, then you're good. Kanang humana ang procedure, calibrated na imuhang burette at 25 degrees Celsius. Now for the calibration of the volumetric flask, it's the same thing. You have to weigh a clean dry flask to the nearest milligram. It's like it's the volumetric flask na automatically, then i-fill nimo tong volumetric flask until the graduation. Syempre, isa lang man ang graduation no sa volumetric flask. So, tapos after filling it with water, you weigh it again. So parehas lang gihapon ang procedure class from with the pipette and the burette. Ano lang gihapon. Pero this time di na ka mag-transfer ang volume ang pipette magud og burette, it transfer sa nimo siya sa container and ang container ang imuhang i-weigh. This time ang flask mismo, empty flask, i-weigh nimo, i-fill nimo with water, and then i-reweigh nimo siya. Una na siya, ang imuhang i-reweigh din hikay flask plus water na. And then that's the same procedure class, kanang kwaon nimo ang weight sa water, i-minus lang nimo flask with water minus empty flask. You will get the weight of the water. Pag nakuha na nimo ang weight sa water class, it's the same thing. You will still use this formula to get the volume being delivered. So kailangan gihapon nimo ning table na ni to get again the true volume na na-contain sa imuhang volumetric flask. So for example, imuhang volumetric flask kay 100 ml. So dapat pag compute nimo sa true volume, mag-agree siya nga 100 ml jud siya. Okay, kung dili, you have to like repeat the procedure again until mao ni siya ang atuang limit. Okay, ang difference sa true volume ug sa apparent volume. Okay, the same procedure sa pag-compute. Questions? Wala. O nag-information overload na ta din hang side. Di pa na ko ni siya i-quiz karon syempre kay